Hi, my name is Alex Kamitan, and here's my submission for laboratory exercise number 7, week 012. Okay, for this task, I was asked to convert the following address to binary numbers: 201.17.29.4, 192.168.1.1, and 172.0.0.0. Okay, so to convert it to binary, first I need to create a table. So based on bits 1 to 8 and going to down to 1. So for 201, okay, let me open my calculator. So 201 is since it's greater than 1 to 8, we know it's 1 to 8. It has number 1 here. So 201 minus 128 equals 73, and 73 is greater than 64, so we put 64 here, then minus 64, 9 is greater than 8, so we put 8, 9 minus 8 equals 1, so 1. So this is the IP address, the binary number for first octet. Then next is 17. 17 is greater than 16 but less than by 32, so we put 16. Reset. So 17 minus 16 equals 1, so it should be 1 here, so I put 0 here. Okay, then next number decimal to convert is 29. 29 is less than 32 but greater than 16, so it should be 16. 29 minus 16 equals 13. So 13 is greater than 8, so we put 1 here. Oh, sorry. Then minus 8. This number is 5 is greater than 4. So we know it's 1. 5 minus 4 is 1. So this is the binary number for 29. Alright. So last is 4. So we know it's 4. We don't have to compute anything. Okay. Then next is 192.168.1.1. So then 192 is greater than 128, so we know it's 128. So 192 minus 128, 64. So we know 64 is 0, so we don't need to compute anything. Okay, next is 168. So 168 is greater than 120. So here, let's compute the next binary. 168 minus 128. 40 is less than 64 but greater than 32, so we put here minus 32 plus 8, so we know 8 is the next number, so 8, don't need to add anymore because 8 minus 6 equals 0, so 1 is 1, 1 also 1, so this is the binary for 192.168.1.1. slow. Okay, so last is 172.0.0. So 172 is greater than 128, so 1 there. 172 minus 128 equals 44. 44 is greater than 32, so 32 minus 32 is 12, greater than 8, so 8 minus 8 was 4. So that's the last number, because 4 minus 4 was 0. Then since this is all 0, I think don't need to put 0 here. Okay, so I don't need to define the rest. We know 0. Okay, so now to compile our answer, it's 1 1 0 0 1 0 0 1 dot 0 0 1 0 0 0 1 dot 0 0 1 1 1 0 1 dot 0 0 0 0 1 0 0. So this is the binary conversion of this IP address. For this one is 1 1 0 1 2 3 4 5 6. Then it's 1 0 1 0 1 0 2 3. Then okay, 7 0 3 6 7. Okay, 6 7 8. Just copy. So this is the conversion binary of the 192.168.1.1. Here also 1 0 1 0 1 1 0 0. Is it correct? 2 4 6 2 4 6 8. Oh yeah, it's correct. So here is 0 1 2 3 4 5 6 7 8. 1 2 3 6 7 8. 6 7 8. So this is the binary conversion of 172.0.0.0 IP address. So now this one is convert to IP address. So there's 1 in 128, 1 1 0 0, then 1 1 1 1, then 5 0 1 2 3 5 3 1 3 0 1 3, then 1 1 0 1 0. So 1 0 1 1 2 3 4 5. Okay, so here is the calculator again. So 1 2 8 plus 64 plus 8 4 2 1 8 4 2 1 should be 207. Next is, no, this is 7. Next is calculator for this. I'm really good in math. 16 plus 8 to 1, 8 to 1, so it's 27. The next is 1 to 8 plus 32. 32 is 160. So the answer for this is 207.7.27.160. Okay, right, let's back to the question here. So we already answered the binary conversion here, also the binary to decimal. So next is, what is the network address in binary? So the network address of binary here is 1, because this is the network side. So 1 here. So let's 1, 2, 3, 4, 5, 6, 7. So this is the network address in binary. Then subnet mask in binary, as we know 255.255 is all ones. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 2, 3, 5, 6, 7, 8. That 0. 2, 3, 4, 5, 6, 7, 8. Okay, so that's the subnet mask. Then what is the prefix length? Prefix length is we just add all the ones. So it's 16 plus 8 is 24. So prefix is 24. In the network address, underline the network portion, check the host portion. So the underline, this is the network portion, and this is the host portion. Okay. Next is, okay, to answer this question, why do we need to convert the decimal value to binary numbers? Because we know computer only understand binary numbers. So for us to compute, to know the IP address, how it computer read it, so we need to convert to binary numbers. Then number 2, while our computing device have an IP address, is it possible to have a similar IP address among end devices? Explain your answer. So for the first segment question here is, yes, we need the IP address in each computing device, because it's considered one host is considered one IP address. So each computing device must have its own host IP. Is it possible to have similar IP address? Yes, is it possible? Since it's individual computers, so if you have a static IP address in your network, so there's a possibility that you have a same IP address. Now, if you want to make sure there is no similar IP address on the network, what you can do is set up your DHCP server, and automatically assign on the IP address, so they will have a different IP address. Then for number 3, what is the importance of the subnet mask? Okay, subnet mask, we know we use it to know the network side and also the host part of the IP address, and also this is very useful in doing subnetting for us to get how many hosts in a certain given subnet mask. Then number 4, what can you conclude from this activity? So what I can conclude this activity is I learned about how to convert decimal IP address to binary IP address, and vice versa from binary to decimal. And also I learned the importance of IP address and also the subnet mask in the network. That's all, and I hope you enjoy your viewing.